Okay, this is a super fast and probably boring video on how to solve exponential and logarithmic equations. So it's from all the stuff from A3, just in case you need some last minute help for the test tomorrow. Okay, so there's tons of different strategies, so I'm just picking the one that comes most obvious. So 4 to the power of 2x equals 1 over 16. So to me, I can see that 16 definitely can be written as a base of 4, because 4 squared is 16. So I'm just going to change mine to 4 to the 2x equals 1 over 4 squared. And then instead of having the 1 over business there, I know 1 over something usually means it has a negative exponent. So I'm going to change that to 4 to the power of negative 2. And then since my bases are the same, I can make my exponents equal to each other. So 2x equals negative 2, and then I just solve for x. So I'm going to divide both sides by 2, so x equals negative 1. And you can check your answer by subbing it in. Okay, next question. 2 to the x plus 1 equals 3 to the x minus 1. So this one, I don't see an obvious way to make the two bases the same. So I'm going to take the log of both sides. So I'm going to take the log of 2 to the power of x plus 1 equals log 3 to the power of x minus 1. And then I'm going to use my power law of logarithms. I'm going to take the exponents and write them in front of the logs. X plus 1 log 2 equals x minus 1 log 3. And then I'm going to separate those brackets. They're in front of my logs, so I'm going to make it x log 2 plus log 2 equals x log 3 minus log 3. And then I'm going to move all my x's on one side. So I'm going to take anything that contains an x. So x log 2, and then this x log 3, I'm going to move that over. Whoops. And make it, negative x log 3. And then I'm going to keep my negative log 3 here. I'm going to move positive log 2 over, so it becomes negative log 2. Okay. I'm just going to try to move things up. Okay. So now I'm going to factor out an x. So I have log 2 minus log 3 equals negative log 3 minus log 2. And I'm going to divide both sides by log 2 minus log 3, because that's what I want to get rid of here. So I'm just going to divide this side by log 2 minus log 3. So my final answer is x equals this whole thing here, which you can solve. It'll be a decimal, or you can leave it in that form. Okay, next question. 2 to the x plus 2 minus 2 to the x equals 24. So right away I see that they're being minus. This minus sign here is kind of in my way. So immediately I know, hey, I'm going to factor out a 2 to the power of x. Because if I can factor out a 2 to the power of x, then I won't have that minus sign in between my 2 to the x's. So if I factor this one by 2 to the x, I know that leaves me with 2 to the 2. Because our exponent law, when we're multiplying, 2 to the x times 2 to the 2 makes it 2 to the x plus 2, because we add our exponents. Minus, and then when I divide 2 to the x by 2 to the x, I just get 1. Equals 24. Okay, and then I'm just going to simplify the brackets. 2 squared minus 1, so that's 4 minus 1 is 3, so I have 2 to the x times 3 equals 24. Then I might as well get rid of my 3. I'm going to divide both sides by 3. So 2 to the x equals 8. And I know that x equals 3 because I know 2 to the power of 3 is equal to 8. But if I didn't know that, I would just try to think of, hey, 2 to the power of what equals 8? Oh, 2 to the power of 3. So anyways, x equals 3. Okay, next. Okay, so we got log base 2 30x minus log base 2 5 equals log base 2 12. Okay, so plan. Okay, I'm thinking I'm going to use my law of logs to combine these two for starters, because I know they both have the same base, so I can write it as log base 2 of 30 times, oops, it's b minus, So 30x divided by 5 equals log base 2 of 12. And then if I just simplify 30 over 5, that's 6. So I have log base 2 of 6x equals log base 2 of 12. And then I'm going to use a different strategy and say, hey, since my logs both have the same base, I know my, like, these arguments must be equal to each other. It's like saying 2 to the power of something equals 6x, 2 to the power of something equals 12. So those things have to be the same. So 6x must be equal to 12 since they're both log base 2. So if I divide both sides by 6, I get x equals 2. Okay, next. Okay, so this guy, I think I'm going to use another law of logs. So since I have two logs added together, it's nice to have just a single log on each side. So I'm going to have log base 7 of x plus 1 times x minus 5 equals 1. And then I'm thinking I'm going to switch it to exponential form. So I've got base of 7 to the power of 1 equals my argument here, x plus 1, x minus 5. So then I'm going to have to expand and collect everything on one side. So I'll have 7 equals, if I totally expand this bracket, x squared minus 5x plus 1x is negative 4x minus 5. And then I'm going to move my 7 to the other side, so I get 0 equals x squared minus 4x minus 5 minus 7, which is minus 12. And then I'm going to check if I can factor this, because I think that's the only way to solve this quadratic here. So anything that multiplies to negative 12 and adds to negative 4, I'm thinking 6 and 2. X minus 6, x plus 2, that works. So then x is equal to 6 and x is equal to negative 2. But if I'm checking for extraneous roots, then I'm thinking I better check these and make sure they're not going to give me a negative in my argument. So if I sub in a negative 2 plus 1 here, that's going to give me negative 1. And we can't take the log of a negative number. Also, this is going to give me negative 7. Whereas when I sub the 6 in, I'll get positive numbers. So this right here is not going to be a solution. Only x equals 6 is a solution to this question.